beginning, the mood all changed. I've been chewed up and spit out and booed off stage, but I kept rhyming and stepped right.
So in today's era of modern athletic training, the use of weights in training has become increasingly popular as a form of strength training, especially among the youth. According to a study conducted by the Nationwide Children's Hospital, nearly 1 million weight training related injuries were treated in U.S. hospitals between the years of 1990 and 2007. Through the use of weights, fitness training has generated more sports injuries that can be associated to incorrect lifting form while attempting to perform these standard exercises. That unfortunately puts unnecessary and awkward stresses on body parts. In order to prevent such injuries from occurring, weightlifters need a device that will assist in correcting form, ensuring that repetitions will not be performed in the improper position, and increasing efficiency during weight training.
The purpose of the system was to analyze movements of the human body during weight training exercises through a device that captured all the necessary measurements that would assist in determining if correct form was used. To do so, all the specific measurements to analyze were identified and corresponding devices were located and compared in order to find the most optimal device for completing the analysis. All of our initial ideas for detection included angle, force, position, and acceleration. We decided to choose Microsoft Kinect that encompasses all measurements required to determine exercise form.
The software component of Lift Plus was built entirely in LabVIEW. Lift Plus begins when the user is prompted to enter username and password information corresponding to his or her account. Once inputted, the user is prompted to select which exercise to perform, bicep curl or push-up. Lift Plus then asks the user how many repetitions he or she would like to perform in the given set, and after a short delay, the user is allowed to move into place and get ready for the set to begin. In this instance, Miles has chosen to perform a set of 5 bicep curls. The front panel has 3 LEDs, one indicating contraction, one indicating extension, with both combined to form full range of motion, which is helpful in increasing efficiency, and a third LED that indicates error. In the form of the bicep curl, error is caused by the elbow protruding outwards, which adds rotational stress on the rotator cuff, or when the shoulder elevates, which puts stress on the lower back. After completing the set, users see a dialog box that indicates how many errors occurred throughout the set. The data is stored in a file that allows for the users to see how his or her progress has developed over time. After finishing the set, the user can indicate whether to go back to the home screen or to perform another set, as well as a short dialogue that shows improvement rate versus the last set. The most important feature of the front panel is the live stream video of the user performing the reps with an overlay skeletal depiction placed. This allows for the user to observe position of joints as well as angles formed, both of which are helpful in form detection and form analysis. Lift Plus would have the Kinect strategically positioned at an area in the gym where users could easily operate the system and begin working out. One of the features we are specifically proud of is the integration of Lift Plus with a handheld device or a tablet.
Lift Plus has been configured for use on personal devices and tablets, so you can take it with you to the gym for easy use.
The tablet carries the same functionality as the computer and is still very user-friendly. The Lift Plus user interface was intended to be as clean and simple to use as possible. Moving forward, we would like to optimize sections of the data storage and form analysis section to expand on other possible ways of injuring oneself when performing strength training related exercises.